you have learned everything and all of the basics that you need to know to create a project in Spring Boot. Now, in this project, we will create a super nice project that will help you connect artificial intelligence to your application. In this project, we will use Gemini as it is super simple to connect. This application will be to create a games using Gemini and arcade games like old ones that you knew before, like Mario and like Snakes and Starships and all of those nice old games and Tetris and all of those nice games and even something new. So let's start by creating a new Spring Boot project. Let's give it a name of Gemini Game Arcade. We will use Maven, YAML for the properties, and now we will add all of our dependencies. So click next. Now let's add the web dependency. We will use basic REST, so Spring Web. We will also need Spring Security, so we will add Spring Security right here. Great. Now we need to connect to the database, so JPA, so Spring Data JPA. We need also validation and Lombok, so validation, and also let's for validation right here. Now we need PostgreSQL runner because we will use Postgres SQL database, so Postgres SQL driver. Great. And we also need the flyway migration, and we will add the JWT when we will start. We also need H2 for our testing, super important. And those are all of the dependencies that we can add from right here. All of the other dependencies we'll add manually. So click on Create. Great. So now let's finish with all of our dependency that we needed. So first of all, let's go to our POM.xml file and let's add all of the rest of the dependency. Now scope for the H2 database scope, you will change it into test. We will use it only in test. So let's add the rest of the dependencies. We can add those right here. We will add JJWT, store dependency, JJWT, and we will need the implementation NPI and Jackson. So Jackson, create dependency JJWT implementation, and finally JJWT API. So we got this. So now let's add our Gemini dependency. Now before we will add this dependency, we will first need to add dependency manager. So right here, dependencies management, because we need to add Spring AI. So it will be real quick. Dependencies, dependency. Now artifact ID will be spring-ai-b-bom, and it will be from the group ID of org.springframework.ai. Now the version will version 1. Type will be POM for POM.xml. So type POM, and finally the scope will be import. So scope will be import. Now let's add the dependencies, or can add this right here. So new dependencies. This will be for the Spring AI. So spring-ai-tableter model for OpenAI. In a moment, I'll explain why we use OpenAI if we want to use Gemini. Let's load it up. And great. And now we have this started. Now we use OpenAI, and it doesn't really matter if you want to use Gemini because Google just get those requests. We can use Google model, we can use Gemini models, and we don't necessarily need to use just ChatGPT's model if you don't like them. But if you have API key for ChatGPT, you can use that as well. So it's more like whatever you prefer, but it doesn't necessarily matter because it's work really much the same. But personally, Gemini is better use case for our application. So to application YAML, we can remove the name, doesn't necessarily matter. Now let's add all of basic configuration. We'll start with all of the data source and all of this stuff. In short, we will also create a Docker file to actually run it. So let's just use data source. Now the URL, we'll use JDBC, PostgreSQL, local host, and 5432 slash init will be arcade.db. We will spin up a Docker image in a bit. So now you have special instruction for Cloud right here. Remove the place where I talked about the other configuration apart from the dependencies. Great. So now let's add a Docker file to run our database. So So new file, this one will be for Docker Compose, so docker/compose, and it should be a YAML file. So let's just real quick rename it into .yaml. So now let's add to our Docker Compose the services, and we will add our database. So in services, well, Postgres, we will add the image of Postgres. We can use at 17, which is the latest version. Let's add the container name, which will be arcade-db, and let's add restart rules, and it will be unless stacked. And for the environment variables, so first of all, it will be PostgresDB for the database, and best rule is to use environment variables, so we will use hard-coded value right here, and we will move it into environment variables later. So for right now, we will use plain text, but for security, before production, we'll move all of those into environment variables. So let's add a comment also right here, move to env file. Great. The DB will be arcade-db, arcade-db, the Postgres user, so Postgres user will be just Postgres, and finally Postgres password, so Postgres password will be Postgres password. Really simple. Now let's add the port mapping. So ports, and we will map 54324 in our machine to the container 5432. Great. And finally, let's add the volumes. So volumes, so Postgres dash data var PostgreSQL dash data. This will be for our volumes. And finally, volumes, and we'll use Postgres data. Great. So this is our Docker file, and now let's build it up. So in the terminal, we will run docker compose app with the d flag, and it will take a few times. So I'll come back to you after our database is completed. So now we have our Docker image up and running. We can use Docker PS to show up all of the processing that's running, like here is our KDB that we have just called the containers. So great. So now let's go to the YAML file and add all of the configuration for the database. So now let's go over to the YAML file for all of the configuration for the database. So right here, click. Now let's add the configuration. So data source and the URL. Now you already know. So JDBC column PostgreSQL column dash, and the URL is local host on port 5432, and it for arcade.db. Now the username is the username that we decide right here, which is Postgres. So username Postgres, and password is Postgres dash password. Yes, it's dash password. Great. Now let's add flyway. No, flyway we don't actually need to do this. Now we can add more configuration, but we will do it as we go forward. So now let's create our first DB migration. So right in this folder, we'll add a new file, and we'll call it v1, and this will be for the users table. So users table.sql, click enter. We will add it to the database. Now let's add the first migration for creating the user table. So create table users, and we will create it real quick. First of all is the ID. We need ID. We can use big decimal and long or UUID. Doesn't really matter, so we'll use UUID as it more secure. And it will be primary key. Great. Now let's add the username. So username, real quick. It will be varchar of 50, so varchar of 50 characters long, and it will be unique and not null. So unique and not null. Auto completion is great. Email, email will be also varchar, but this one will be varchar of 254, 255. It will also need to be unique. We don't want duplicated email, so someone will not be able to sign up with the same email multiple times. And if it does, we tell them, hey man, listen up, this email is already exists in our database, in our system. If you really want, you need another email for it, for another account. Password, now the password will be varchar of 1024, because we will hash the password, so they will be really long, longer than they will be at the start, and this is of course not null value field. And we can also add fields like first dash name. It will be varchar of 50. It could be nullable. We can also add for the last name, so last name. And enabled, we'll add the enabled. We can add all sort of fields right here, but those are the really necessary one for the user ID, username, email, etc. We can also, of course, add more fields and more stuff, but this won't be really that necessary. But let's also add less field, which will be for the role. The role is very important. It will be super simple field for a varchar of 50 character because and it will be not null. Because think about it like that. The role is user, can be a admin, and that's like the user that you can have. Maybe if we have a subscription, sub user for subscription. So sub user for subscription. So it's a very short, so we don't need too much. And by doing that, we will make sure that we will use every byte for our database. And this is our user table, and now we need to create the entities. So we need to migrate everything. We will do that in a bit. When you first run your application, everything will migrate. So now let's create our first entities in the Java. All right, so until now we create packages in Java like entities or repositories or controllers. But when you create a real application, it's better to encapsulate all of the logic for a certain area. Like if we have an e-commerce application, we have products for everything that is connected to a product, like the repository, the entity, the controller, the service, the product service, maybe even some special configuration. And if we have orders, so orders as well. So by this logic, we encapsulate all of the logic of the user in one folder. So we can call it users, and we will add right here the entity, the repository, everything. So we'll add the user entity, so user, and real quick, entity table, because we created from the database, we need to use name, and it's for the user table. And now let's add the primary ID. So quickly, we already know how to do this. ID, and this is a UU ID, not a long. And let's change the generated method for UU ID. Great. Now let's go over right here, and we need to add username, email, password, first name, last name, and role. All of those are string. So let's add those real quick. Username, password, great, email. We have first name and last name, so also role, but we also have last name and first name. So string, first name and last name. Great. So we have all of our fields that we needed. Now we need getter and setter, and since we are lazy and don't want to write it all ourselves, and this is a lot of boilerplate, let's use Lombok real quick. So getter, setter, all args constructor, no args constructor, and also let's use the builder if we ever want to use the builder pattern. Great, so we have the user. Now let's add really quick the repositories. So interface will be the user repository, and it will extend the JPA repository. Great, nice auto completion, and we will use the repository annotation. Now we can add the user endpoint, but this user endpoint should be really secure and have a lot of stuff going on around it. So first of all, let's create the test for it, and then let's create the actual code. So first of all, let's create the authentication and security test for our users, because this is what users usually does. So to the test folder right here, we'll add a new Java class, and this one will be for authentication. So auth, we can also call it user, but I prefer auth because it reflects more about the real purpose of the users, because the users is mainly for authentication, so it's really important. And for the controller, so we only want to test the endpoint and not the actual implementation, which is the general idea of testing. Let's add this as a class. Now let's add the Spring Boot test, or in the moment we'll add any annotation for test. This will be a test class, but first of all, let's add the Spring Boot test. So Spring Boot test annotation. No, this is test class, and we'll use auto configure mock MVC because we will use mock MVC. And let's also use active. Let's change our profile. So active profiles, and we will use the test profiles. So in the test profiles, let's go right here in the resources. Let's create application test YAML file. So new file application test YAML. For the YAML, let's just copy all of the YAML stuff. Great, but for right here, let's paste it. Now we will change a few things. First of all, we will use in-memory h2 database. So h2-mim test db, and we will add a mode. In short, I will tell you what it does. Mode equal to PostgreSQL. Mode just tells tell h2 how to exactly act, because we use it for testing. It should know exactly how to act. So for the username and for let's remove password, we will use like SA for username, something like that. Really. But now let's add the JPA hibernate configuration. Hibernate and DLL auto, and this one will be the configuration to how exactly it will handle the restart of the application, or when we have testing, each test runs in its own compartment kind of thing. So it will not like run everything at once. Each test will get its own running environment. So every time that we stop the process, what we need to do, we need to use the create drop. So it will drop all of the data of the database and recreate it again for us for each individual test. So we have clean environment for each test. Now let's add flyway configuration. We'll use enable and we'll set it up to false because we false, exactly that. So we don't actually want we don't actually want flyway to handle it. We can just use h2, which will just create from the entities itself. Doesn't really matter, but it will be better for our test. Now let's add the JWT stuff, because we don't add those. So JWT, and we will add those into the production and development application YAML file. It will have the secret, and it will also have the expiration. Now expiration will be 84 and expiration. Yes. And for the secret, we can just create real quick the secret from the terminal. So open SSL and dash base 64, and we'll use 64, and it will create us the secret. Great. Copy secret. Nice and easy to the same line. Great. Now we can just copy the JWT, because later we will add all of the Gemini stuff and all of the configuration for that. But for now, we're testing the security of the application. So right here, let's add all of those configuration for the JWT right here. We'll use the same secret. For development, doesn't really matter. For production, this will move to environment variable. So now that we handle the profiles, let's go into the controller test. Real quick, think about every business owner you know, the restaurant, the consultant, the coach, that local business trying to grow online. Most of them have a website. Most of those websites are doing nothing. They look like they were built in 2012. They don't convert. They don't represent the business, and the owner has no idea of how to fix it. That gap, that is literally why you are learning this, because businesses need people who can build things that actually work and actually look the part. Polaris is a studio that serves exactly those businesses. They build, design, and experiences for companies that are serious about their digital presence. No templates, no drag and drop, real work, built from scratch, build to convert. If you know a business owner in that situation, or if you are building something yourself, send them to the Polaris.studio website. It's the kind of work that reminds you what's possible when design is taken seriously. Link below. So, alright, let's go back into the course. So, right here, we will add a few fields. So, first of all, the mock MVC. We need AutoWire for it, and it won't be final field. Now let's add a few more fields, few more things that we needed. We need also object mapper for the mock stuff, and also we need user repository and the password encoder. So wired for the user repository, so user repository, and also we need wired for the password encoder. We will define all of the settings and all of the actual code later, so don't worry about it. In this project, we'll use TDD, as it is really great to create all of our tests, then implement the logic, and then we see everything came together. It's really nice. So now let's create a few tests to ensure that the login is working, that the get user for the specific user is working, and that we can also change passwords, because those are really important functionalities. So let's do this. Before that, we will create a method that will run before every test. Now this method will ensure that we're starting off a clean database, which means we will delete all of the users that we might have left from previous tests. Then we will save one user to the database for all of those tests. So let's do this. Now we will use the before each annotation to tell Spring Boot that this method will set up every test. So first of all, we will delete everything, and then we will save a new user. So we will use the save method, and we will use the builder pattern. So we'll use user.builder, and now we will build it. So first of all, we will add the username, because ID is created on the server. So username, and the username will be Alice. Then the email will be alice@test.com. Then we'll add the password. We will encode the password, and now let's add the role. Now we will add a few roles, and we will just ensure that we have them. So role is a string, as we defined earlier, and it will be a regular user. So we will add a few options. We will add user, sub user, short name for subscription user, and finally we'll have the admin. But think about it. We need an admin, so we'll add also user and sub user. That's all. Now we also need to define first name and last name. So first name, it will be Alice, and also last name, it will be Alice Jean. Think that's how you write Jean. Hope that I'm not mistaken. And finally we will build it. So build, yay! And don't forget the semicolon. So this is our setup method. We first of all delete all of the users, and then we will save a new user to the database. Now let's create the first test for the login. So test, this one will be login, and it will be, now let's define what it should be, with valid credentials, and it should return the token. So with valid credentials, return token. Now let's add that this could throw exceptions, because our endpoint would throw not found exception, an unauthorized exception, etc. Now let's use our mock MVC. So mock MVC dot perform. Now we need to perform a post operation. So post, and now let's go to the endpoint. It will be /API/auth for authentication, and it will be /login. Now the content type. Now we actually need to import it from that. Yes, we imported from the wrong place. Now the content type will be JSON, so we can just click tab, and the content will be object mapper dot write value as string. Now we will add a new login request. We will create this DTO in a second. This DTO will take the name, so Alice, Alice, with the email, with the password of 1, 2, 3, 4, 5, 6. Great. Now let's just organize a little bit so it won't look ugly. Content on a new line, and there you got it. Now we will expect, we will expect the status, so status to be okay. So is okay. So we need to import it right from there. Great. Now we'll also expect that the token will not be empty. So headers, and we will expect that the JSON path will return a token. So token, and we expect that it will not be empty. So is not empty. Now the only thing left for this test is to create the actual login request. It will be a record that will take username and the password. So new Java class, we will add it in the DTO folder. So DTO.loginRequest. Should be a class, it should be our record. So we can change it into a record and add those right here, and it will be take a string username and string of password. We also need to add a few more validations. So right here we'll add the not empty, the not null. Let's add the not blank just for fun, and let's do this as well. So we'll add those validations. So we have our first DTO. Now back to our controller, we just need to import it. So let's import this class. Now let's create a few more tests. Those one we will do them faster. So test real quick. So void login with invalid credential, and it will not return token. It will return 401. So return 401. Right now, let's implement it real quick. So mockmvc dot perform post to this endpoint. Now the content type will be JSON, and the content itself will be object mapper of this. Now instead of this right password, we'll change the password to 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the wrong password. Now we will expect the status to be is unauthorized, and that's this test. So for our next test, this one will be for get user. So test. Now we'll add another annotation with that call with mock users. So we bypass the login, and this user will be Alice. Now void, we will call it get username name, and it should get the name get, and it should be successful. It can also throw errors. So let's use the mockmvc and perform a get operation this time, and we will use get username. We will not get the username, we will actually go to -me, because when the user is already authorized, we can just go into the token and just take it. We don't need any external stuff. Now we will expect status to be okay, and we will expect the username not to be empty, and also we will expect JSON path of dot username to be Alice. So and we'll expect the value, so -value to be Alice. Great. Now this is the happy path. Let's go to the not so happy path. So we can just change it to be or unauthenticated. So we will remove them with mock user. So right here we will perform. So mockmvc perform not password.me, and we will expect the status to be is unauthorized. Very simple. And this is for our test. Now for our next test, we will use the mock user and we will try to change the password. So just change. We will call it change password, and it will be for a successful one. Full. Nice. Now let's actually do this. So mockmvc perform a post operation for change password endpoint. The content type will be JSON application, and nice auto completion, and we'll use and right value as string. Now we need new DTO. This DTO will be for the change password request, and it will take the first password, so 4, 5, 6, and this is the new password, so the old password and the new password, so this will be new password. Now before we create this DTO, we will just check that this was actually successful, and we will expect the status to be is unauthorized. So is unauthorized. Now let's create the password request. So copy it and create this new DTO. So new Java class, we will pick record, change password request, and it will take the old password. So old password and new password. Now we can actually copy all of the annotation from here. Oh, to save time. Great. Copy those. Great. And there you have it. We can also add another annotation for the size, and maybe we'll add some rules that the size of a password could be of minimum of 6 characters or 8 characters. Depends on the security that you want. Let's pick up 6 for it. So we can also validate if the password is too short. We know that. So if we have a really short password, we will know it. So that's for it. We can also write here for the password for this DTO. Now let's go back to our test. Let's just import it. Great. Now for the final test, we'll check out what's happened if we are trying to connect with the wrong password. So it's really important that we'll be really explicit about what we exactly testing. So with wrong old password, and it should be not successful, really simple. So OpenBC, we will perform a post operation to the change password. Next, the content type will be application JSON, and the content will be right in screen. Now it will be new password and will be wrong old password. So right here it will be wrong password, and this will be like 1, 2, 3, 4, 5, 6. Doesn't really matter. let's just add wrong with that. So this test will not be failed just because of the size, but because of the actual logic. And we will need to add another one of those, and we will expect to be unauthorized. So really simple. So we have all of the tests that we need for our endpoints. So now when we run all of the tests, we expect all of them to fail. So we can run it, run test, and all of those were failing. Now this is not bad, and we expect that. So do not just like worry about it, because this is the whole idea of TDD, that we create all of the tests and then we create the code. So now let's implement all of those endpoint one by one, and you will see that all of our tests will be running. So now let's start to create our securities endpoints and all of the logic behind the scenes. So first of all, we started with the JWT provider. So let's add this new service that will generate, validate, and parse everything. Let's create the JWT class. So child class, it will be JWT util. It will be a class, and we will add a nice service annotation, not size, service annotation to it, and we will add the all arg. We don't actually need, because we will use so now let's add the few variables that we need. Only two fields we need right here. So the JWT secrets and the JWT expiration. Okay. We don't actually need a constructor for it, because we will use the value annotation like magic, and we will need the JWT dot secret. We can just use that, and right here we'll use the value annotation, and we will use JWT t dot, I don't like to write expiration too long, expiration. Great. So it will inject the value from our YAML file. Now we will need the get key annotations, the get key method. So private, it will return a key, and it will call get JWT key, and we will return. So let's create our first method. So this one will be private for the class. It will return a key, and it will be called key. Now this one will return keys. Make sure that you write keys and not just key. Use this method, shared key, and use the JWT secret. We will get a byte, and we will need to tell them how it should look like. So standard UTF-8. I'm sure that you remember everything from our Spring Boot course and in the security section, so we will go over it quicker and less time. So it's important to me to say it so you won't be overwhelmed by the speed. So now we will generate our key. We'll use the JWT's builder to generate it. So it will be a public method, because we need it to be a public, yes, and we call it generate token. It will get username, not user, autocompletion wrong this time. So we will get a string of username and also a UUID of the ID. We'll call it user ID preset, and we need to import the UUID from the Java utils. We will return the builder, and we will start with setting up the subject. So set subject, and the subject will be the username. We will create the claims, and it will be user ID, and we will add user ID. Now with issue at, so set issue at, and we will set it new date, so when it will be created, and expiration, so set expiration, and we would set it with new date, and inside it we'll use system current time in milliseconds, and we will add it the expiration time, so JWT expiration. Now we will sign it up with the key that we get from right here, and we will compact. So this is how we are generating our JWT tokens. Great. Now we need the get username, get user ID, and valid method, and the isValid method from our JWT util class. But before that, we need another private method. So private, and it will return a claims, and will be called parse token. It will get a token, and it will return JWTs dot parse builder key, and we will get a body. So we will use the parse builder with our key, so it knows how we created it, and it will get the claims, which is ID and the username. So Now we are here for the fun part. We finished with all of the boilerplate, boring user security stuff, and now we are creating the main feature of our application, the AI connection. And to do this in Spring Boot, it's really easy, it's really simple. We need to configure a few things first. So let's configure it real quick. Let's add a new table to our database to save the data of the AI response. And let's start with the configuration. So right here resources, let's right here add new configuration for the AI. So now we're using OpenAI, so use OpenAI, right? Now for API dash key, we will add an environment variable for that. So we'll use Gemini API key. You can get this key. You can get this key right here in the AI Studio application. So you can search out for aistudio.google.com/applications, and right there you will have the get API key. You will click on it, you will generate a new API key, and you could use that. Now let's add the base dash URL for the AI. It will be https://generative-language.googleapis.com. And now let's use Gemini Flash 2.5. So we just write in chat, and we will use options, and we will use the model, and we will configure it to be Gemini 2.5 Flash. Great. So those are our configuration. Now let's add a new migration. So new file, and this will be for our migration, and it will be called v2 generated dash game table. So table dot sql. Now let's add this. Now let's create the table. So create table, and we will call it generated games. And right here let's add the ID. The ID will be a UUID, and it will be the primary key. Great. Now for the user ID, it will be a UUID, and it will be null, and it will reference the users in the ID folder, in the ID field, and on delete cascade. So those are just simple rules. Now this error happened because it doesn't necessarily see that, or it doesn't migration, or, and let's continue to our next on delete cascade, and now let's add on delete cascade. Great. Now let's add the game type. So the game type, it will be a varchar of 50 characters. So varchar of 50 characters, and it will of course be not null. Now the game, let's give it a name. It will be varchar of 255. It will be a not nullable. Now let's have the game code, the actual code that the AI will generate. It will be a pure JavaScript. It will be a JavaScript code that could be rendered in the browser, and it will be of type of text because it's a really large text file. And it would also be not nullable. And next, let's add the prompt, and we will It will also be text and not nullable. And that's for our table. Now let's add the create index on IDX. And now we got this. Now we can create indexes on the user ID and all this stuff for optimizing search. But now let's focus about the functionalities and less about additional features. So as we have it, let's add our new table right here. Let's add right here, new. It will be in the games folder, so games dot, and it will be the generated game repository. So plus let's add all of the necessary annotations. So the first one will be entity. Now let's add the table annotation and let's add the table name right here. Go to, and this was generated games. Now let's add the ID. Click on that. We will use UUID and we will add the UUID right here. And now let's go to the resources and well, we can just copy those fields, but it's super fast. It's user ID, game type, game name, game code, and prompt. So let's try to remember it. So let's use UUID, user ID. Let's add the game name. We have the game name, game type, game code. So we also have of game type, also game code. So game code. And we also have the prompt, so string. Prompt. Right now. Great. So now let's add a few annotation to the user ID because we need to point it at the right table. So first of all, it's many to one, and we will use lazy loading because one user could have many games, but one games is belong only to one user. But all of those games could belong to one user and one user only. So this is it. Now let's use the join column, and the name will be user. So let's add the name. It will be user ID. Great. We can have more configuration if we want at the entity. Now we can add another annotation for the column at the game code and prompt to tell that this specific column is using text and not just a normal string. So column, and we'll add column definition, and we can have text right here. We can copy it and just put for the prompt as well because this is also a text area. Now we are using the user ID. We won't do it like that. We will use the user as that. So now we have our entity. Real quick for repository. So new class repository. Oh boy, generated game repository. extend JPA repository, not long, it's UUID, bed auto completion, and let's use the repository. Great. Now let's connect Gemini to our application. We did it in the environment, in the configure. We already configure everything needed. Now let's just create our chat service. So Java class, let's call it, um, let's put it in the AI package, and let's call it AI, or AI like that, AI client. Looking good. Let's add the component and require our constructor. Now we have one field that we need, so, and this one will be to connect to the AI. It will be the chat client. Now this function would be really simple. We need just a function for creating games and returning a string with the response of the JavaScript code. So let's call it generate games, and the arguments will be one string of game type, so game type, and one string of user prompt, so user prompt. Now let's implement it. Now first of all, we need to have the prompt right here. We should have the prompt, and then we need to return the chat client. We will make the call. We will put right here the prompt. We will make the call, and we will return the content. So it's super simple. This is everything you actually needed to connect with AI. The dependency, little configuration, and this is how you actually connect in code. Really simple. You could write him something like say hello, and he will say hello, and all of that. So now let's write the actual prompt. So triple quote right here, and let's add the instruction. So we first of all give our AI a role. So you are an expert game developer. So developer. Generate a complete playable, and we will add right here a placeholder for the actual game type, arcade game. Now let's write in JavaScript code using Canvas API. It would be better to using the Canvas API. Now, we don't actually need to know what the Canvas API is, so real short, the Canvas API is an API allows front-end user to write high moving stuff. Like when you have a game, what's happened every second you write something and then you delete it, and then you write again, delete, write, delete. So the Canvas API allows us to do this with JavaScript code and do this in the browser. So this is the level that we are aiming for. Now let's add additional requirements, and we'll add the user prompt. So elements, and we'll have the user prompt ifig, and now let's add a layer of validation that the AI will basically validate itself. It is not 100% bulletproof or work every time, but it's still good to tell the AI, listen up, validate that the code is actually good and working. So validate the code and ensure that it's working. So it is working. Now a few simple rules. Return only JavaScript code, no markdowns, so no markdowns file, and no explanation, so no explanation. So it will return only the JavaScript code itself. Now it's formatted, game type and user type. Now this percentage type in string is a placeholder, and you write the type, the first letter. Like for string you write S, for integer you will write I, for long you write L, etc. And then we use the formatted, and we add the placeholder values. The, watch out that the order is really important, because if you will put those differently, right here you will have the prompt, and right here you will have the type, which is not exactly what we want. So there you have the AI client, super sweet and quick. And now let's create the game service. So right here, focus, and it will be for the game service. Let's add a few annotations. First of all, the service. The other one requires as constructor, and we'll use the transactional annotation because we will create a few transactional, because some of the operation right here, some of the method will be transactional. So now we need a few fields. So the first one will be the AI client. The next one is the game repository. So generate game repository and game repository. And the last one will be for the user repository. So we need user repository as well. So user repository. Now, before we will start, we need a few DTOs to define the response and the request. So right here, games, new class. This will be a quick record, and we will receive a game request. So the game request would look something very simple. String of game type. So game type and string of game of prompt. And let's add another line annotation to here, and also right here, not blank. Now let's define the game response. Let's put it in the details package if we are doing that, and we will also remove the game request to this package, new record, and we'll call it game response, and the response will be a UUID for the ID, a string of game name, string of game type, so string of game type, and the game code, so game code, and that's for our simple response. Now let's move this to the TTO package refactor. Great. Now to our game service. We have all of the details that we are actually needing. Great. So now let's create a method to generate. So the simple method to generate. So we will call it generate. Super simple. So it will generate, it will get the username first of all, so string of username and the game request, and it will be a request. Great. Now let's implement it. Now user will find by username, and if we will not found, we will throw. Now for the code, for the actual JavaScript code, you can call it code or JS code. Let's call it just code for now, and we will go to our chat. We will go to our AI client, generate game, and we will use request get game type and request prompt. Now let's generate our game, and now let's create the game. So generated game, it will be the game. Let's use the builder pattern for it. So generated game dot builder. Now let's use the builder. First of all, the user ID. Let's change it real quick right here to user, simple user. So user, and we will have the user that we find. Now let's add the game type, and we'll add request game type. Now for the game code we can add it. Now for the game name we'll add the request game type. So request game type, and we will add to it a dash and the exact time that you have created it. So system dot current time milliseconds. So we will have the type of the game and the time that has been created. Now for the prompt, we will have request prompt, and finally we can build it. Now let's map the game to a game response. So game response, it will be a new response. And now let's add all of the needed fields. So first of all, it's the ID. So it will be a game dot get ID, and we will get the game type, the game code, and the prompt as well, and we'll have our response, and we will need to save it. So we will save it, and we will return the game response. Now we have all of this logic that does not belong into this file. So we need to ask, this is a mapping. It does not belong to this file and belong to a mapping service. So let's create right here the mapping. So the new Java class, this will be an interface that will define it will define exactly what mapping will be. So we will call it game mapper. Right here we'll have all of the interface definition for the method. So mapper, and we will put it in the mapper folder, not folder, package. Interface. Let's add right here the component, and real quick we will use, it will return a game response and not map to game response, it will be to response. And let's create an implementation of it. It will be a game mapper implementation. It will be a component as well, and it will implement the game mapper. Now let's implement the method. It will get a response, and now let's go right here. Let's take this line, let's cut it from here, go to our implementation, paste it, and let's just return this. Now we see a little problem that we have when we rely on autocomplete. We don't want a game request. We actually want a simple game. So from generated game, simple game. So that's it. Go to our implementation. Let's change it into a simple game and we'll call it game. Yes. Now everything is working. So we have our mapping. Let's go to our service. We can remove those lines and we can return mapper. Let's So now we need to add our mapper field. So right here, and it will be a mapper. So game mapper, and we will use it. Now we will return game mapper to response game, and now we actually need to save it first. So let's use the generated game repository dot save method and save it. So now let's create our final method, our next method in the game service, which will be to get all of the games for a specific user. So it will return a list of game response, and it will be find all by user ID, and we will find all of the games by the user ID. So first of all, let's find our users. So or else it will throw. Great. Now let's check if for the users. Now let's get all of the users. Now let's get all of the users game. So generated game repository, find by user ID. Let's keep it in a var, so we won't need to deal with the types, and we'll call it games. It will be a list of optional games, but let's deal with that. So user ID. So user dot get ID, and or else we will throw an arrow. Now if we do have it, we don't need to throw an arrow. Let's map each object. So let's use stream and let's use map, and it will use game mapper and to response methods. So method reference, and it will make those into a list. Great. So now we can return this list. So now let's return games. We can actually make it shorter if we just return right here, and we can remove this part, make our code cleaner. So this is for our service. Now let's create our controller. So real quick, new class, and it will be the game controller. Now rest controller for the request mapping to tell Spring exactly where to find it. We'll use /API/games, and it will be require our constructor, and we will only need the game service. Now we need for generate. So first of all, we'll use the post mapping. So post mapping, and it will be at /generate. It will be a public. It will return a response entity of type game response. And it will also be called generate. Now in the request body, we will find the request, and we want also to validate the request. So let's use the validate, and we also want to have the user. So we will need to use the principal. This is the users. Now we can return our response entity with the status of 201 created, and in the body we will have the game service dot generate, and for the username we'll use the principal dot get name, and for the request we will add the request right here. So this is for our post to generate all of that. And now for our get mapping, so get mapping to get all of the games for specific users. So it will be a list of game response and it will be called find all. And we are needing the principal right here as a parameter. So principal, principal, principal. Now we will return response entity. Type OK. Now let's use the game service dot find all by user ID, by user name, principal dot get name. Now we actually need a username, so let's change it into a string, and it will be called find by username. And we change here to username as well. Now everything fitting, and this is our controller. Yes, I also think it's too simple. So this is everything you actually needed to do. Now for our test, we create a mock for the Gemini service. So we won't actually need to make real API calls. So now let's create our test. New class. This will be for our controller. It will be called game controller test. Now let's add a few annotation. We can have the spring boot test. We can have the autoconfig mock MVC and also active profile. And this one will be for the test. And now let's create the actual test. But before that, we need to have a few fields. So first of all, auto-wired for the mock MVC and for the object mapper and for the AI client. So auto-wire AI client. Yes. Well, let's make a few spaces between those. Great. Now let's create the before each method. So we will set up everything needed and then we can just destroy it. Now, before each setup. Now, when we can import it, when AI client dot generate game is called with any string and any string right here. Now we need to import this method. Now when it will call with any string and any string, we will then return fake code. Great, so now we have our setup. Now let's create a few simple tests. Now all of those tests will be with a mock user. So let's start with writing the first test. So test, we will add the with mock user, and this user will be called Alice. Alice. Now void generate game, and it should return game with code. So it can throw the exception, and right here MVC perform post operations. So post, we will import it, and it will be to /API /games /generate. Now the content type will be application JSON, Now let's add the content itself. First of all, let's organize it. And right here we'll have JSON, we'll have object mapper, right value is string, and we'll give it the new game request. So game request, and it will be snake, and we will add classic game. That's all. Now we need to validate a few things. So first of all, and we will expect the status to be created. So status, and we will expect this status to be is created. We also need to import status. We will import it, and we will also expect the JSON path of game code. So dot game code, and the value to be this fake code that we have. So value to be fake code. So fake code. Now we'll expect also that the type will be, so game type will be, game type will be of snake. So those are so this is our happy path test. Now let's create a new test to get all of the games that we have. So test, and with mock user, this user will also be Alice. And yes, those expectations are great. So now let's implement this test. First of all, we need to create an actual game, so we can just copy all of this code. We will have also extra test. We can remove those tests. We just want to create it, so we will perform it. And we will use mockmc, and we will perform a get operation. So we will use get to /API/games, and then we will expect that the response, let's just import this static method, and we will expect the status to be okay, so is okay, and we will also expect, so we will also expect JSON path $, which means the root, the value to be array, so is array, because even if we have only one value, it should return an array. And now our final test. Let's check out what happens if we are trying without a user. So just test, and it will return the void, generate game, and it should return for oath, should return unauthorized. Just that. Now let's perform the operation. Now we can just perform the same operation that we did right here, and just change our expectations. Instead of expecting to be is created, we are just expecting to be is unauthorized, and we can just remove those one, and those are all of our tests. Now we will run all of our tests and see the green bar. And now let's run all of our tests and watch the green bar. And as you can see, all of our tests are now passing Now let's check out our other testing. So let's run the test, and everything running. So all of our tests are up and running, up and passing, which means our application well structured and well built. So we finished this course. It was a pleasure for me to help you along this journey. If you have anything that you think can be used of improvements, I would love to hear it down in the comments. I also love you to tell friends and family about this course and local businesses that you know that really try to grow big and become better in today's online present and needs a fresh brand new website that help establish their brand. I would love you to tell them about the Polaris Studio. And this is for today's course, and I will see you in the next one.